Hey everyone, today we are going to take a look at Data Augmentation Visualizer. So we have often heard AI requires a lot of data for training, and we're going to take a look at what exactly is this raw data, how is it trained. So I'm going to dump some raw data file over here. I'll be dumping the text file, which is shown over here. So it is Alice Adventure in Wonderland. And then I'm going to process it. So pre-processing is the part where this data is tokenized, and what it does is essentially lowercase every word or depends. And this is one tokenizer which I'm using from PyTorch. That's how it works. And it divides the sentence or this whole paragraph into different tokens. Further, during the augmentation, what we are trying to look for is, let's say we just had this amount of data which we have in the pre-processing. During the augmentation, we can add some context to the data, which can help increase the data set. So basically, one of the augmentation which I'm using is random word insertion. So basically, just add some, hopefully some contextual words. Again, I'm using PyTorch, so it depends on what kind of WordNet is able to predict what's a good word over here. So it's just adding some words over here, important, interesting, which are pretty repeatable. In the second one, second augmentation is where I'm increasing the data set by adding synonym for the word. So for example, over here, Alice Adventure in Wonderland past. Actually, this is by, and the synonymous is past. So this is kind of a weird kind of algorithm, but even if I click another time, this is going to process it in a little different way. That's how text is done. Let's take a look at how an image would be processed. So this is just a rooftop. So if I'm training my model that this house is really large, or this house is really small, or if this is even a house, how do you actually let it know? So what I'm doing in the image normalization is trying to convert it into basically a grayscale, but it looks a little blurry just because the way it is being normalized into a colorful image. In the augmentation, what I'm trying to do, just give it some random rotation. So the training model knows that houses will not be only in one particular direction, and there could be another rotation as well. So over here in the second augmentation part, I'm adding some random brightness, increasing. So if you can see over here on the left, the red color is brighter. On the right, the red color is slightly dull. That's for the data augmentation part. Let's take a look at one of the 3D object. This didn't work out well, but this 3D object looks something like this. When I hit process, what it does this is just during the pre-processing step, it is just centering the object, so it is not allowing it to move. And during the augmentation, I'm just giving it a random motion and the scale object. So the scaling is not working really well over here. Further, the last data type we can take a look at is this audio. I think this is interesting. So this is how the audio originally sounds. During pre-processing, what we're trying to do is basically lower the scale or resample it to 16,000 hertz. This was sampled at 48,000. This kind of, let's take a look at this. And as a part of augmentation, I'm lowering or increasing the pitch, but the voice is same. So yeah, that's how the pitch variation changes the data or adds more input to the data. And over here in the background noise, I'm just adding some honking noise, but this is basically a high pitch. So essentially, we are increasing the noise or trying to give more context. So when you're, for example, training voice model, which should capture your words, but in a noisy environment, that's how it would work. That's a brief preview about how we can visualize the data for augmentation. Thank you.